Hello, and welcome to the second part of our webinar series, Powering Sustainable and Reliable Energy Distribution with the SF6-free Blue GIS from Siemens. We are focusing today on the next generation digital GIS. Our session today will last approximately 60 minutes and will include a Q&A session in the end. Please note that since you cannot ask your questions directly while we are presenting, we invite you to type your question during the presentation in the Q&A box. We will try, of course, to address all of your questions after our talk if in the Q&A session, but should some of your questions remain unanswered due to lack of time, we will make sure that they get addressed after the webinar concludes. You should be receiving then the answers to your questions via email. This entire session will be recorded and made accessible to you immediately after the webinar. My name is Leila Lukovac-Denzel, and I'm a Product Lifecycle Manager for medium voltage gas-insulated switchgears for primary distribution. And today with me is also my dear colleague and a key expert for sensors and actuators, Ben Schupferling. Ben, would you like to introduce yourself to the audience, please?
Sure. Thank you, Leila. A very warm welcome also from my side. My name is Ben Schupferling, and I'm the responsible Product Lifecycle Manager for digitalization, instrument transformers, and secondary systems within our gas-isolated switchgear.
Thank you, Ben.
You're welcome. So let's have a short sum up from the first part of the webinar with a focus on next generation sustainable GIS. Leila, could you please tell us a little bit about the required transformation to more sustainability?
Yes, Ben. The distribution grids of the future will look different than today. The electrical grid was originally designed for large centralized generation sources delivering power in one direction to consumers. But in recent years, several factors such as increasing customer demands, policy changes, technological advancements, and so on, have driven the power system to evolve. Increased demand for renewable resources, electric vehicles, distributed energy resources, and electrification in general ensure that the structural requirements of the future electric network will differ substantially from those of today's grid. Growing energy demand, for example, by electromobility, as well as decentralized infeed from various producers, bring us new challenges. Furthermore, there are increasingly aggressive targets in terms of decarbonization and sustainability goals, driven by regulations, but also by our own responsibility.
Okay, Leila, when you say responsibility, you mean individuals or Siemens? So Siemens is a pioneer and driver in sustainability?
That is correct, Ben. But it is really necessary that we all take a clear stand here on this issue, not only on corporate Siemens level, but also on individual level. In 2023, the world experienced a record CO2 emissions. It was not a good year in terms of climate change. It was the hottest year worldwide since record began, with an average temperatures around 1.5 degrees above the values of the pre-industrial era. So global CO2 emissions reached a new record of 37.4 billion tons. And now, as we stand at this crossroads of environmental transformation, it is crucial to adopt strategies and technologies that not only match our energy needs, but do so responsibly. And Blue GIS plays a fundamental role in this challenge.
So the main target of developing Blue GIS was to reduce CO2 emissions?
Well, primarily, yes. So our mission was to develop a sustainable digital switchgear, which will help our customers to become more energy efficient, preserve resources, and of course, reduce CO2 emissions.
Mm-hmm. So in the last webinar, our colleague Miriam presented also the F-gas regulation in the European Union. which will ban the use of SF6 in medium voltage applications starting from 1st of January 2026.
Yes, Bernd. So Miriam and Kartik discussed the F-gas regulation, which plays a significant role in the European Union's effort to fight the climate change by controlling and minimizing emissions from fluorinated gases. The timeline for the F-gas regulation, particularly for electrical equipment, shows us the European Union's commitment to systematically reduce the use of these gases. For a successful transition to F-gas-free switchgear market, we need to provide viable alternatives and for a range of operational needs, ensuring environmental goals are met, but without compromising grid reliability.
Mm-hmm. So this is why we are moving away from the SF6 towards F-gas-free solution, right?
Yes, that is exactly the reason. So traditional switchgear solutions have long relied on the use of sulfur hexafluoride, or how we call it SF6. It has been used for more than 35 years in electrical system. It is ideally suited for an insulating medium in terms of its dielectric properties. The gas is also non-toxic, non-flammable, and does not have any carcinogenic, mutagenic, or reprotoxic characteristics. And it insulates 2.5 times better than air at given pressure, which of course enables then a very compact design of the switchgear. However, SF6 is the most potent gas, greenhouse gas, known if released into the atmosphere with a lifetime of around 3,200 years, which is extremely long-lasting. And now considering that each switchgear panel contains around 50 to 75 tons of CO2 equivalent of SF6, and considering then the overall number of medium voltage functional units using SF6, if we take, for example, Europe installed base, we can get easily the comparison that trapped SF6 in the GIS in Europe has a CO2 equivalent potential of around 160 million cars driving for 1 year. This value is, of course, theoretical, as SF6 remains in the hermetically sealed stainless steel vessel throughout its operational lifetime. But so it is very important aspect, the end-of-life handling of SF6 gas and recycling process, which needs to ensure that no SF6 is released into the atmosphere.
Mm-hmm. So we needed a solution that would replace SF6, but still keep all the advantages that SF6 GIS switchgear provides to our customers, correct?
Yes, Bernd, that is correct. And that is exactly what we needed, what our customer expect. The same compact design, ideally identical footprint to the existing SF6 panel, maintenance-free design, which ensures low life cycle costs, modularity, personal safety, environmental independence, and the same long-lasting service life. But all that now combined with the minimized CO2 footprint that enables ecological or so-called green energy.
So I am sure that our audience would be interested to hear what were the major challenges of the F-gas-free switchgear development and how Siemens tackled them.
Well, as I already said earlier, SF6 has played a key role as an insulating and arc-quenching medium in distribution networks, particularly in switchgears. And now eliminating SF6 requires finding a different way to achieve not just equivalent insulation properties, but also a proper alternative to its outstanding arc-quenching capabilities, while not jeopardizing environmental, operational, health, and safety achievements well known from our proven SF6 technology. And if we talk about challenges, I would like to list the following 4 major challenges of the development, which are insulation, switching thermal management and a request to monitor the condition of the new gas technology. So technology paths, if we talk about the insulation, were either to choose between natural origin gases with reduced dielectric strength, alternative foreign gases with dielectric strength somewhat similar to SF6. And the third path would be a completely different technology, as, for example, air-insulated switchgear or switchgear with solid insulation. So Siemens decided to choose the path with the clean air, using only natural origin gases with increased pressure and then modified design of electrical field. And now if you look back to the European F-gas ban, it was certainly a right decision.
Okay, but replacing SF6 as insulation medium with clean air while increasing the pressure inside the vessel has only solved one challenge out of your forementioned challenges. What about arc quenching in the load break switch?
So one of the approaches for SF6 free load break switching technology was or would be to use circuit breakers with vacuum interrupters found in switch gears of primary distribution level. However, since the secondary distribution level mostly handles load switching tasks to distribute power in the local grids, such vacuum circuit breakers are oversized and therefore not cost efficient. So the vacuum interrupters, which are installed in the primary current path, they are also exposed to a constant power flow and load. And also we additionally need a second device to meet the safe isolating distance requirement outside the vacuum tube. So all in all, technically possible solution, but rather oversized and expensive for the application. Then another possible approach for load break switching is a so-called buffer switch disconnector. And in this design, the filling gas does not only act as an insulating medium, but it's also responsible for extinguishing the switching arc. A wide range of properties have to be taken into account, including arc extinguishing behavior, the electric performance, regeneration capacity, and last but not least, deposits and gas contamination after arcing. And as there is a long life experience for the buffer switch technology in combination with the natural origin gases, Siemens decided to go for an alternative with the well-proven, known vacuum technology using a vacuum interrupter for arc quenching, but now in the auxiliary path, so-called blue switch.
Okay, so later, before you tell us more about this exciting and innovative blue switch, maybe you tell us shortly how you managed the third challenge of the F-gas free design, the thermal management.
Thermal management. So when it comes to thermal management, a number of design changes and optimizations needed to be implemented in order to achieve the same ratings with the gas that has lower heat dissipation compared to SF6. And one of the most prominent measure was to increase the pressure inside of the gas chamber. And in addition, there are use of some different materials, then introducing heat sinks, in some cases also active ventilation. And for some typicals or panel typicals, there was a need for derating performance reduction, for rated current, for example.
Okay, thanks, Leila. But now our audience can imagine that developing an SF6 alternative solution was not an easy task and took a lot of time, resources, and efforts. And the result of this development is our Blue GIS product family. So, Leila, what stands behind Blue GIS?
So, Bernd, Blue GIS is a combination of a clean air as an insulating medium, the switching principle, which is based on the proven and efficient vacuum switching technology, but all the benefits of the gas-insulated switchgears are maintained for our customers regarding, for example, footprint, service life, or reliability.
I am sure that our audience would like to learn more about clean air.
For sure. So clean air. What is clean air? Clean air is an insulating medium which exclusively consists of components of an ambient air, such as nitrogen, oxygen, or carbon dioxide. It is free from fluorine compounds, very important, and therefore also extremely safe regarding toxicity, flammability, or material compatibility. And with a global warming potential less than 1, it has no impact on our environment. In addition, an installation without fluorine gases has minimum demands when it comes to training for handling the gas mixture, its transport, the switchgear installation, and of course later switchgear operation. And moreover, and also very important, is that there are no regulation on the documentation or reporting of clean air. So since clean air contains only out of components of the ambient air, when the switchgear reaches its end of life, there is no need for gas recycling as we know it from the SF6, but clean air then can be released into the ambient air with no issue. So when we consider all this, the switchgear with a clean air offers an economic benefits throughout its product lifetime.
Later, but to come back to the innovative blue switch as a SF6-free alternative of a 3-position load break switch, I would like our audience to understand its principle of operation and also its benefits.
Yes, Bernd, you know that Siemens is a pioneer when it comes to vacuum technology, and in the medium voltage application, Siemens has used vacuum interrupters since 1977. It is a proven technology suitable for all switching applications. And now moving away from SF6 and developing a blue switch, Siemens extended the use of vacuum switching technology for also so-called switch disconnector tasks. So what is a blue switch? Blue switch is a 3-position load break switch with vacuum interrupter in so-called auxiliary path. It combines a make-proof switch disconnector, a make-proof earthing switch, and a vacuum interrupter in parallel current path for arc extinguishing. On a first picture on the left-hand side, you will see the blue switch in a schematic diagram. Marked with number 1 is a busbar contact, which is connected with the busbar of the switchgear. On the right-hand side of the busbar contact marked with the number 2 is a sliding contact, or so-called auxiliary contact. And these two contacts form this so-called auxiliary path to which a vacuum interrupter is attached, which is marked with the number 3. And the number 4 is the cable feeder contact and also part of the circuit of the switch. And it transmits the current to the switchgear's cable feeder connectors. An earthing contact is marked then with number 5, and it is connected to the ground busbar via compartment housing. On the pictures on the right-hand side, you will see the 3 switching position, which will be selectable by a pair of switching blades. The switching position on transmits the current from the busbar to the cable feeder or vice versa, which is therefore called main path. In switch position off, the current flow is interrupted and the disconnecting function is fulfilled. Hereby, a safe isolating distance is provided by a gas-isolated contact gap and not across the vacuum interrupter, and the switch position earth then safely grounds the cable feeder.
Oh, impressive. And what is the exact role of the vacuum interrupter in the auxiliary path?
Well, Bernd, it's the current interruption during a braking operation. This very small vacuum interrupter is stressed by current only for a short period of time during a braking operation. So in switching position on, the vacuum interrupter and the auxiliary path are not active and no current flows through this path. And when the switch gets the off command, the current commutates via the moving switching blades from the busbar contact to the auxiliary contact. And in that way, it's redirected from the main path to auxiliary path. When blades reach the sufficient dielectric distance to the busbar contact, the vacuum interrupter opens and breaks the current. So during the short time which is needed for the current breaking, the switching blades still slide across the auxiliary contact and prevent any arcing in the gas compartment. And then they move further, leaving the auxiliary contact without the current, and ultimately also reach the off position.
So Leila, thank you very much for this really detailed explanation of the blue switch and its technology, which I think was a major challenge if we talk about ringmain units in the secondary distribution level. For the primary distribution level, the major challenges were, I think, insulation and thermal management. Maybe now you can show our audience the available Blue GIS portfolio and the roadmap of the upcoming developments.
I will do. So the good news is that on the primary distribution level, up to 40 kA and busbar and feeder current up to 2,500 amps, we already have a portfolio available up to 24 kV as an SF6 free switchgear. We have available two types of switchgears, so-called NX plus C24 for the busbar current up to 2,500 amps, feeder current up to 2,000 amps, and short circuit current up to 25 kiloamps. This switchgear is available for single busbar system at the moment and is also available at the exact same footprint as NX plus C product, which is our well-known SF6 product. For the primary distribution level, another switchgear that is available that has sales release is so-called ADAB24, up to 24 kV, short circuit current 40 kA, and the busbar and feeder current up to 2,500 amps. Very important to say is that ADAB24 is available as a single and double busbar system configuration and is SF6 free successor of our well-known ADAB10 product, which with SF6 with a single pole encapsulation, which is a very unique feature in the market. When we talk about voltages higher than 24 kV, we are now in the final stage of development and testing of our Blue GIS switchgear ADAB40, which goes up to 40.5 kV, 2,500 amps, and 40 kA. And this switchgear is also part of our ADAB product family, also single pole encapsulated, so the face-to-face faults are excluded in this type of switchgears. And we will be starting pilot projects for ADAB40, hopefully by end of this calendar year, and we're planning also to have a sales release for the first market package end of next year. So when it comes to secondary distribution level, we have two products available on the market, ADGH12, up to 12 kV, 20 kA, and 630 amps, and ADGH24 up to 24 kV, 20 kA, and 630 amps. Higher ratings will be covered by so-called switchgear ADGH40, which is currently under development and will be available according to the due dates defined then in the F-gas regulation for 36 kV.
Thank you very much, Leila, for these really very impressive insights in the technology and the portfolio of Siemens F-gas-free Blue GIS.
Well, it was my pleasure. But now let's focus on digitalization, which is next to sustainability, the second main driver for our Blue GIS. Could you please explain us a little bit more about different digitalization offerings for medium voltage switchgear, especially for the Blue GIS?
Sure, Leila. We have the classical and well-known digital offerings like automation, protection and measurement, as well as communication. Basis for all these offerings are our cProtec and CCAM devices, which are widely installed in our switchgear and connected to control centers via standardized IEC communication protocols, like the IEC 61850 or IEC 60870-5-104. Remote FATs and services have become very, very important, especially during COVID times, where traveling was even not or only allowed with restrictions. So we have in this time expanded our offering very fast, and it is used very well since then. Condition monitoring in combination with IoT applications is actually the most popular and most important digital offering in our portfolio. Installing sensors to verify the health status of the switchgear or to give a prediction for a necessary maintenance to prevent further failures and damages of the components is a significant benefit to our customers.
So it is impressive how many digital offerings you are already providing. But what actually happened? What changed in the electrification and automation sector that now everybody's talking about digitalization?
Yeah, the integration of more and more renewable energy supply with volatile generation and also the volatile loads like e-car charging, heat pumps, and generally the decarbonization with the need of more electricity brings the transmission and distribution grids and the installed components more and more to the limits. Therefore, it is very important that the stability of the grid is still given and shutdowns will be avoided. Also, aging assets have to be more and more monitored to prevent that they will fail. And last but not least, skill gaps and aging workforce is a human problem which can partially be solved with condition monitoring and also with remote inspections.
So, sounds reasonable. But you mentioned now several times condition monitoring. Could you tell us a little bit more about what kind of monitoring Siemens is now already offering?
Yeah, sure. Let's take one of our primary Blue GIS, what you have already shown before, the NX Plus C24 Blue GIS as an example. We have integrated sensors for temperature and humidity monitoring to detect abnormal operating and ambient conditions. The circuit breaker can be monitored to prevent switching failures. Electrical insulation can become damaged over the time due to faulty or incorrectly installed components on our switchgear. As a consequence, partial discharges may occur. Our partial discharge monitoring system provides an early warning, allowing to prevent failures and damages on the switchgear. Gas density monitoring reports a warning in the very unlikely event of a gas loss. And last but not least, current and voltage transformers connected to an intelligent short circuit and earth fault indicator, like our CCAM FCM Plus or protection relay from our cProtec 5 family, can monitor the load flow. Those monitoring functionalities are available either on-premise, in SCADA, or also as a cloud-based IoT application, like the different feature sets of our Electrification X. Electrification X is a software as a service offering to tackle the challenges of the energy transition with different feature sets like load management, network fault management, asset management, sustainable energy management, distribution grid management, and last but not least, a continuous OT asset inventory and patch management.
Very good. So, you are offering monitoring functionalities on-premise, in SCADA, and also a cloud-based IoT application. And does that mean that our customer needs to decide already with ordering the switchgear which way of monitoring he would be using eventually in his?
Not necessarily. So if we have a look on the architecture of our monitoring solution, we have either in the switchgear or somewhere in the substation level one centralized gateway from our CCAM A8000 RTU family. This RTU collects all the sensor information either directly from the sensors or from intelligent devices like the already mentioned cProtect 5 or CCAM FCM Plus devices. This gateway is able to provide a connection to the cloud level or into the control level, or even both levels in parallel are possible. Also, an on-premise solution with an HMI installed in the switchgear or substation level can be realized with the same gateway.
That's perfect. So with your gateway solution, the switchgear is already prepared for all possible ways of monitoring, and this can also be retrofitted then in the future. Our audience must have seen an internet description of this webinar that you are the face behind the so-called Siemens solution intelligent transformer substation. Can you tell us something about that? What is intelligent transformer substation?
Yeah, that's correct and clear. I can explain it a little bit. So I have defined around 15 years ago with some already retired colleagues the three-level concept for so-called intelligent transformer substations. The first level was monitoring, the second level telecontrol, and the third level load flow control. When we have now a look on today's challenges for the DSO, the solution to solve them is principally the same as in former times. Only name has changed. And we are talking now about digital secondary substations instead of in former time intelligent transformer substations. Those substations are mainly compact subs made out of concrete, metal, or even more sustainable out of wood. The SF6 ring main unit is meanwhile in many cases replaced by a F-gas-free ring main unit, like our ATJH24 Blue GIS. Several sensors, as described earlier for the NX plus C24 Blue GIS, are also available in the RMU to monitor the status of the switchgear and also the grid operational data. Visualizations of all these data can be done on-premise, in the cloud, or in SCADA.
Okay, so the monitoring functions that you now explained to us earlier in the Blue GIS switchgear NX plus C24 are all also available for the ring main unit, right?
Principally, yes. And like we can see on this slide, we provide the same solutions for more asset and grid transparency also in our ATJH24 Blue GIS. As you may imagine, the space for possible sensor installation is there even more limited due to the compact design compared with the NX plus C. Especially conventional voltage and current transformers or non-conventional alternatives, so-called low-power instrument transformers, which are required, for example, for load flow monitoring, can only be heavily installed in such compact ring main units. Therefore, I'm proud and happy that we have managed in the meanwhile to integrate the current and voltage measuring in our cable connection bushing with low-power instrument transformer technology. This smart and intelligent bushing has an integrated Rogowski coil to measure the current and a capacitive divider to measure the voltage. Both are designed to the instrument transformer standard IEC 61869 and providing 22.5 mV at 50 Hz at 50 amps for the current measuring and a transition ratio of 10,000 to 1 for the voltage measuring. The accuracy class is 0.5 for both voltage and current measuring. We have an additional temperature sensor integrated, which is on the one hand side used for compensating the voltage accuracy along the whole temperature range of -40 degrees up to +115 degrees. And this sensor can secondly also be used for further supervision of the cable connection to detect abnormalities caused by incorrectly installed cable plugs. And last but not least, we have the standard VDRS voltage divider integrated, which is used for verification of the absence or presence of the voltage.
Wow, so this is a major innovation that Siemens done. And a 4 integrated sensor is in such a small component. But will our customers have a further advantages from C-bushing?
Yes, Leila. We are contributing also to the topic of sustainability with our innovative C-bushing. It provides massive material savings of iron, copper and cast resin, as its weight is only around 1.5 kilo per piece, compared with conventional CTs and VTs with a weight of up to 50 kilogram per piece. Further simplification of the project execution is given due to the one-fits-all design. We have only one C-bushing for all voltage and current ratings in the factory stock. A later upgrade of grid parameters is also possible without adjusting or replacing any components. And last but not least, also safety on site during commissioning and testing is higher due to low voltage outputs and no need of cabling or installing of instrument transformers around or on the cable.
Very impressive design of your C-bushing. And when I say your C-bushing, this is on purpose because I've heard that you have been the one initiating the idea back in 2018. You also pushed this through the contest so-called Hello Future. And you were actually accompanying the whole process also from the R&D side until the sales release, right?
Yeah, this is correct. And as you may can see, how many additional gray hairs I got in this time, or even lost many of them. But finally, I'm happy that we have now this innovative bushing available for all our GIS switchgear with outer cone Type C bushings. Together with the 7SY82, which is a universal protection relay with LPIT inputs, or the so-called CCAM FCM Plus as a short circuit and directional indicator, we have a powerful system application in our portfolio. It provides functionalities for protection, indication, as well as load management, network fault management, and distribution grid management.
Very good. So thank you, Bernd. To sum up everything what we've heard in our today's webinar is that Siemens is already offering a wide spectrum of sustainable medium voltage portfolio with incorporated digital features. We are now at the end of the second part, Next Generation Digital GIS, of our webinar, Powering Sustainable and Reliable Energy Distribution with SF6-free Blue GIS from Siemens. Thank you very much for your interest. We are now available for your question. I see some questions came in during our presentation. So I will start with the first one. And please note that if some questions remain unanswered during the session due to lack of time, we will be addressing them in written, as I said also earlier. And these answers will be then sent to you via email. So now the first question. Bernd, you mentioned the different possibilities of the monitoring the status of the GIS switchgear. How about brownfield application? Could I retrofit the sensor in already existing switchgear, maybe also the ones from a foreign brand?
Mm-hmm. Yeah. Okay, I interpret it in this direction. Yeah. Our colleagues from the customer service department are more than happy to offer you specific solutions for condition monitoring, either on Siemens or foreign brand switchgear. So principally, the sensors could be different, but depending on the switchgear technology, so like when we have AIS or GIS, they have a different style and a different design. But the most important thing is that our already mentioned Electrification X feature sets can handle not only new switchgears from Siemens, but also many other components from us and also from third-party suppliers.
Okay. The next one. But this is also for you, Bernd. So I have one question to the instrument transformer technology in the C-bushing. In former times, you have used different LPIT technologies for current and voltage measuring. what is the reason why you changed from inductive current measuring LoPo to Rogowski coil, and why from resistive to capacitive divider?
I expected this question because more than 20 years ago we started with a different technology. So, reason is very simple. The available space in the bushing is limited, and Rogowski coil for current measuring can be designed in a smaller way than the inductive LoPo which was used in previous versions. And it further provides the advantage of a saturation-free transmission of the primary current more or less up to the full short-circuit current. For the voltage measuring, the change from resistive divider to capacitive divider is also the available space, or the reason for this is also the available space, and the smaller design of the capacitive divider. So the disadvantage which is provided from a capacitive divider is the temperature drift. And this we solved in our design with a parallel measuring of the temperature with a PD100 sensor. This sensor, as already explained, compensates the accuracy drift over the whole temperature range, starting from minus 40 degrees up to around plus 115 degrees, which really can occur in the bushing under full load of the panel. So now I think, we have now one question for you, Leila. What about the operation principle for new portfolio? Do we need a special training for BlueGIS?
Yeah. So when we were developing BlueGIS, the main focus was actually to keep as much as possible the same. So the mission was that our customer who switches from SF6 to SF6-free technology has nothing new to learn, or less as possible. And this was our goal. And the Blue switchgears have the same front design, which is well known to our customer and also well accepted by our customers. Nothing changes for the customer, so for the whole operation remains unchanged. The customer does not have to relearn or do some special trainings. The same levers are used, same interlocking principle. So the only distinction that we made now, we also put a BlueGIS sticker on the BlueGIS portfolio, but that's it. So next question. No. This one is for you, Ben. So, could the C bushing be installed in switchgear in a brownfield application?
Good question, but unfortunately not, as our bushings are welded in the stainless steel switchgear vessel compared with others who are sealing it in. And we have also external LBITs for this application when it comes to retrofit. This technology is the same. And the customer could retrofit then also existing switchgears with the same technology while using the same secondary devices. So this one came in for you, Leila. How many SF6-free switchgears has Siemens already delivered?
Well, I don't have an exact number as of today, but meanwhile, considering primary and secondary distribution, it is more than 10,000 functional units of BlueGIS that we deliver to our customers. Of course, more on the RMU side than the primary distribution level. I don't have now exact ratio in my head, but I think RMU side more than 8,000 units, and primary than the rest.
The rest, okay. So let's look at the next question. Yeah, it's for me. Bernd, I have seen already some years ago an article about your intelligent transformer substation and the so-called self-healing grid application. Is this something you still are providing to customers? Yeah, clear. I know this direction of the question. Okay, sure. The basis in former times was an RTU also. Today we have the CCAM A8000 gateway. And this gateway is connected and was in former times also connected to SCADA. And a self-healing application can be configured in the SCADA level. Our ADJ H24 BlueGIS as a ring main unit normally used in these distribution grids, could be also equipped with all necessary functions for the self-healing grid application, like motorized load break switches and a motor control unit that customers are able to control from remote our ringmain units.
Okay, now there is a question. Can my existing NX Plus C switchgear be extended with SF6 free switchgear without any modification? Yeah. So yes. The answer is very clear. Yes. The busbar system for the NX Plus C24, which is what I already said, an SF6 free version of our NX Plus C switchgear, have the same position and the same height. And since the busbar system for the NX Plus C switchgear is outside of the gas chamber, gas compartments, so-called solid insulated busbar, the extension of the NX Plus C is rather easy, non-problematic. And the same thing applies when it comes to replacement. In case you need to replace one panel or several panels of NX Plus C, you can also do it can be done without any further or special modifications.
Yeah, this is, I think it's for you. When will the RMU for 36 kV be available?
Mm-hmm. This is a tricky one. But as I already briefly mentioned when I presented the portfolio, we are developing the Blue GIS portfolio in stages. There are several reasons behind it. One major reason behind it is that the fact that the higher the ratings, more the challenge. So the first stage and what we focused on, also partly because of the European Union regulation, was to develop 24 kV portfolio. So to tackle at least 80 to 90% of the 24 kV market. So for the RMU for 36 kilowatts and above, we are now starting the development. We are working on it, of course, full speed. I can just say it will be available until 2030 when the European Union ban starts for the 36 kV level. Band, this is one for you. Do you have already reference projects for digital transformer substations?
Yeah. So we do have many, but not all of our customers are allowing us to talk about it. So I'm officially allowed to mention two examples. One is Aral BP substations, which are installed already at hundreds of filling stations in Germany to manage the load for the high-speed chargers for electrical cars. And another application where I have the release to talk about is Netze BW, so big DSO in Germany, where we have already delivered several hundreds of so-called FFU 2.0 substations. So this is a name branded from the company itself, where we installed C bushings, and they are connected to short circuit and earth fault indicators, which are also then connected in parallel to SCADA, into the cloud, and to a so-called management and operation system.
Okay.
So I think we have just time for one last question. This is for you. What is the life expectancy for Blue products?
The same. We expect the same lifetime as from Siemens SF6 portfolio. So there is no downside when it comes to service life expectancy. And this is also stated so in our catalogs for Blue GIS switchgears that the expected service life is around 40 years. So the same.
Mm-hmm. So maybe one very last question. What will happen with Siemens SF6 portfolio? So maybe I think it's also in your direction.
Yeah. What will happen? So we have to understand that the Blue GIS or Blue portfolio is an extension of the Siemens SF6 portfolio. And Blue portfolio fulfills the customer's requirement for more sustainability. However, many of our customers continue to rely on SF6 technology. And on the other side, also, what I already mentioned, we are developing SF6 free products in stages. So not everything is, not all ratings and all features are available as of yet. So as long as it's like that, we will, of course, continue manufacturing also SF6 portfolio. I think that's it. I got the signal that we are approaching the end of the session, and we would like to thank you for your questions and for your interest in today's presentation. Of course, you will get access to the recording right after end of this session, and we will be sending the link to the recording.
Yeah, we hope that we were able to give you an overview about the next generation digital GIS and many aspects where digitalization can provide further benefit to you. We would be glad to welcome you soon to one of our other further upcoming webinars.
So thanks again for your participation, and we wish you a very nice rest of the day. Bye.
Bye-bye.